Today we are going to see Theorem 9.1. Okay, here one and only one circle can pass through three non-collinear points. This is the theorem. Three non-collinear points means collinear points means it will be all the points will lie in the same line. Non-collinear points means all will be indifferent. This A, B, C all are different. They are not lying in the same line. Here the theorem is one and only one circle can pass through all the three non-collinear points. We are going to prove that one circle can be passed through all the three non-collinear points. First you have to write what is given in the question. Given A, B, C are three non-collinear points. To prove one and only one circle can pass through the point ABC. Okay. For this, we are going to do one construction, that is join B to A and C. Okay, this one. We are taking three non-collinear points A, B, C. Down C. Okay, first we are joining A, B and BC. And we are drawing one perpendicular bisectors. Draw perpendicular bisector XD and YE of AB and BC respectively, which intersect at O. Okay, one perpendicular bisector from X to A here. Okay, XD from here, from D to X. Okay, for this AB line, we are drawing one perpendicular bisector, and for this BC line we are drawing one perpendicular bisector YE. Okay, YE, and these two lines intersect at O. Okay, these two perpendicular lines intersect at O. And another one, join O to A, B and C. Now from O we are joining, from O we are joining to A, and from O we are joining to B, and from O we are joining to C. Now we are going to prove the theorem. Okay, for the proof we are going to take two triangles OAD and OBD. Okay, two triangles we are going to take. That means in the figure we are going to take OAD and OBD. Okay, this triangle and this triangle. In this both triangle we are going to compare. Okay, we are going to compare. First we are comparing the right angle. For this triangle, for the first triangle, angle D is the right angle. Okay, so you can write ODA. And in the next triangle, this D is the right angle. So you can write ODB. Okay, so D is the center for that is the right angle. ODA is congruent. This three lines means it is called congruent, that is equal. Okay, more equal to ODB. And here D is the midpoint. Okay, D is the midpoint for the line AB. Here D is the midpoint. Because this is a midpoint, this line AD and this line DB, okay, both will be equal since D is the midpoint. So AD is concurrent to BD. And the next one, OD is same as OD. Here also for this triangle, this is OD. Okay, and here also for this triangle, this is OD. In both the triangles, OD is common. Okay, so OD concurrent to OD. Therefore, if all the three are equal, that means midpoint equal, one line is equal, OD is equal, and angle is equal. If all the three equal means we can say this triangle OAD and this triangle OBD both are equal. That means both are congruent. Okay, these both triangles are congruent. If these both triangles are congruent, we can say OA equal to OB. This line OA equal to this line OB. That means from the center of the circle, if this radius is equal and this radius is equal, Okay, that we have proved. From these two triangles we have proved now. Likewise, the same we are going to prove for this triangle and this triangle. Okay, this triangle and this triangle we are going to prove now. In triangle OBE and OCE. Now the same in these two triangles we are going to see. Okay, for this angle, for this triangle OBE, for this E is the right angle, so you can write OEB. And for this triangle E is the right angle, so OEC. Okay, so these two are congruent. Okay, since E is the midpoint, this side BE is equal to EC. Okay, since it is the midpoint, E is the midpoint. Okay, the same here. What is common in these two triangles? OE, this line is common. Okay, that is OE congruent to OE. So from these three we can find out this triangle OBE is congruent to OCE. Okay, these two triangles are congruent. If these two triangles are congruent, we can write this OB line and this OC line are equal. Okay, if we draw from the center if we draw one circle of radius 2 cm, here also it should be 2 cm, here also 2 cm, and here also 2 cm. That only we are finding here. Okay, so this line OA is equal to OB in the first one. Now we have found out OB equal to congruent to OC. Okay, these two are equal. OB is congruent to OC. If compare now first one and the second one, take this as first point and this one as second one. Okay, so OA equal to OB, here OB equal to OC. If we combine these two, you will get OA congruent to OB congruent to OC. So if this are equal, and the m of that measurement also will be equal, so m of OA congruent to m of OB congruent to m of OC. Okay, that's all. With the center O, we have found out all the three OA, OB, OC are equal. So we can draw one circle with these 3 points.